Welcome back to PV Online, and today we're going to discuss acids and bases, and in particular, pH. Quickly, let's review some of the general properties of acids. Remember, they're in all of our fruits. They give the sour taste. They turn the litmus paper to red, and they're going to react vigorously with active metals. You're going to generate a bunch of hydrogen gas, and they'll react with bases. Some of the characteristics of bases is that they are going to taste bitter. They're going to turn the litmus paper from red to blue. They'll feel slippery. That's why soap, or shampoo, it's got that kind of slippery feeling, and they react with acids. If you have pure water, distilled water, will it conduct an electrical current? And the answer is probably not. We wouldn't be able to see it. And the reason for that is just a very small fraction of water dissociates into the hydrogen ion and the hydroxide ion. So little that if you were to multiply the concentrations of the hydrogen times the hydroxide, you would get 10 to the minus 14th. So the way hydrogen and hydroxide are related is if you multiply them, they will always equal 10 to the minus 14th. So for pure water, the hydrogen and the hydroxide equal each other because for every one water molecule, I get one hydrogen and I get one hydroxide. That gives us a concentration of 10 to the minus 7th. Now these numbers are pretty small, so we come up with a pH scale. And the pH of pure water would be 7, and we say that it's neutral. Now commonly we use a pH scale to measure acidity, and we know that if something's neutral, we say that it has a pH of 7. Anything with a pH less than 7 we consider acidic. Anything greater than 7 we call it basic or alkaline. We have another picture of a pH scale, and you can see that we're most acidic when the pH is 0. So the smaller the number on the pH scale, the more acidic you are. The higher the number in the pH scale means the more basic that you are. And you can see these are just some common items. So a lemon has a pH of 2. That's why people that suck on lemons a lot, they can really erode their teeth. You can see where apples and tomatoes and bananas are. Water, if that's pure water, is going to be a pH of 7. Baking soda, soap, you can see the pH is starting to increase. So let's take a look at this. All the pHs is a measure of the acidity or basicity. The pH scale ranges from 0 to 14. An acid has a pH of less than 7. A neutral solution has a pH of 7. Basic solutions have pH values above 7. Now the thing that's interesting about the pH scale is it's actually a logarithmic function. So a change in a pH of 1 unit actually represents a factor of 10 change in the acidity. So that means if you go from a pH of 1 to a pH of 2, the solution isn't twice as acidic, but it's actually 10 times more acidic. And again, so we just have some common household items of as far as their pH. Now let's take a look at the biological view of the human body. Remember, a pH of 7 is neutral. So gastric juices have a pH that's very low. When you have a pH that is low, that means your hydrogen concentration is going to be very high. So gastric juices are going to be what you have in your stomach. Urine, you can see, has a broad range from 5 to 8. I would imagine it has something to do with what you're eating. Saliva. Saliva has a pH that's less than 7, which means it's slightly acidic, and that's what starts breaking down the food. You've had an introduction to pH. Good luck, and we'll see you next time. your blood is considered a buffer solution, and that's because the pH range that your buffer can function in is very small. And if it has a drastic pH change, that's what happens if all of a sudden you get really dehydrated, the pH change dramatically, and all of a sudden you can start killing off the blood cells and die.